Okay, so we've heard quite a lot now about the biological part of soil health. But of course, as Louis has mentioned earlier, there are, especially in the past, we focused much more on the chemical and physical part. And I was asked to talk a bit on the soil physical changes with crop rotation. Okay, just as a bit of a background, most of our soils, the productivity is quite low compared to other parts of the world, and the reason for that is that many of our soils are of sedimentary origin. That means the mother material was either deposited by water or wind blown, as we see many of the central and western Free State soils. And as a result of that, those soils are low in organic matter and or carbon content and relatively infertile. Our soils are usually also prone to erosion because of the topography that is sloping, the rainfall patterns, heavy thunderstorms, and strong winds. It was estimated that we lose about between 200 and 400 million tons of topsoil annually because of different modes of erosion. For instance, a study was done in the 70s and 80s at the University of Pretoria on a Hutton soil with a moderate slope of around 3-4%, and it was measured that about with conventional farming or practices, about 20 tons of soil per hectare is lost annually. Now, with the yield potential at that time, or typical yields achieved, that related to about 5 tons of soil for every ton of maize was produced. Okay. Of course, soil formation is a very slow process, so I think it's safe to say that in most cases the replacement rate will be slower than the rate of erosion. So that's definitely of big concern. This is temperamental this morning. Okay, so with long-term conventional practices such as continuous maize, monoculture, or short rotation systems where, for instance, we have continuous maize and just 1 year of potatoes and then back to maize. Typical practices such as plowing, the use of inorganic fertilizer, those are practices that were very successful, highly productive, but there were also negative effects on the soil chemical, physical, microbial properties and degradation in the long run. So overall, we could see a decline in soil quality or soil health, and finally this resulted in lower crop productivity and sustainability of production. Sorry, this is really frustrating. So what are the typical degradations that we see? Firstly, surface crusting, water and wind erosion. Because of the crusting, we see lower infiltration. Because of continuous cultivation, compaction layers, increased bulk density in general of the soil, lower soil organic matter, acidification, especially in higher rainfall areas and because of nitrogen fertilization, the mining of specific nutrients because of specific crops, the buildup of salinity, and increase in specific weed, insect, and pathogen species. Of course, that's not related to soil physical properties, but also related to the biological part. So, what are alternative practices that can be introduced to sort of counteract this negative trend under conventional tillage? Well, if we read the literature, and also there's a lot of proof from other research that structurally and functionally diverse rotation sequences can help to improve soil productivity and soil health in general, especially if it's combined with conservation agriculture practices. We've heard Karen speaking about regenerative agriculture. Now, of course, we spoke a lot about crop rotation this morning. If you try and look for a definition, it's basically growing different crops in sequence on the same piece of land with the aim of, in the long term, preventing or avoiding the exhaustion of the soil in terms of the chemical, physical, and biological properties. So the aim is to improve these properties in the soil. Now, if we talk about conservation agriculture, it's practice that's taking off in many parts of our country already. There are three important principles. In addition to the diversification of crops in a sequence, we're also looking at trying to maintain a residue layer on the soil surface and to minimize soil disturbance. Now, of course, if you have a potato crop in a rotation system where there's, it's difficult not to disturb the soil and to maintain a residue layer, but at least it can be done for the rotation crops in between the potatoes in your cycle. So the aim, sorry, jumped now one over. So your aim should be to sustainably and intensify production by creating a healthy environment for the optimal crop production and improved long-term sustainability of your system. So what are the benefits? Basically the opposite of those negative things that we saw with continuous monoculture is soil structure improvement, less soil crusting, improved infiltration, lower soil bulk density, increased soil organic matter content, and increased water availability to plants. Okay, so from some of the previous speakers already referred to this Eastern Free State trial. It's a trial that that has been running for we're now moving into year 10. And we started off with, it's under dryland production. We started off with 4 rotation systems where we have different crops and in some years, sorry, just go back. And in some years, of course, the crops vary. Okay, in this specific trial, we don't incorporate other sort of conservation agriculture practices, so it is still soil tillage and normal practices as is practiced on the farm. Just to quickly, so we started off in 2015, which is 10 years ago, which is sort of our baseline year when there was potatoes on this field, and then we have the 4 rotation systems where you can see how crops vary, especially in year 2. Okay, just go one ahead. So at the end of 2020-2021 cycle, season, we were basically through the first cycle, starting with potatoes the year before and ending with potatoes, and then this is now a repeat. But you will see we at some point we changed. So here we replaced that maize with a cover crop, and here we started introducing cover crops, which I will say a bit more about just now, right? Let's go ahead. So what were the observations that we made? We looked initially at infiltration rate. Okay, please help me move forward. Infiltration rate again. Bulk density, penetrometer resistance, which is being measured there. And then also the chemical aspects. I'm focusing mainly on soil physics, but of course we also looked at the chemistry. right? And soil organic matter. Okay. So I'm just giving you a snapshot here at the end of this first cycle. In season 5, we were a bit disappointed in the fact that there were very little variation in chemical and physical properties, and even microbial properties of the soil, slight differences in pathogens that cause diseases, but not much other differences. What we did see consistently is a decline in the pH of the soil over the years, so liming was necessary, and we saw slight differences in penetrometer resistance. So, and also the yields were very similar. So this was the potato yields after this, at the end of this 5-year cycle, and you could see no significant differences. All right. This is just the year before that. We saw a bit of difference in soil bulk density, so that's the higher the reading, the more dense the soil, and this is soil depth. And you could see a bit of variation, and in this case, rotation 1, which had TEF at that stage, higher density. And I believe it was probably more effect of the TEF drying the soil more out than really a penetrometer resistance difference that we saw. So from a soil chemical physical point, really disappointing that we did not see much differences at that stage. And then we made a decision for the next cycle to start introducing cover crops, and because we could not see differences in organic matter content, which I think also contributed to the fact that we did not see variation in microbial activity. So in this year, we introduced cover crop instead of the maize, so that's a repeat of year 2 in year 7. And already after that first year, we could see, start to see differences, not in the soil chemical physical, but I'm cheating a bit and I'm going to show you a little bit of just one snapshot of the microbial, soil microbial respiration. And that made us decide to, in year 9, to split the plots, the rotations. Half the plots we planted with cover crops, the other half we kept fallow as in the original plan. And the idea of the fallow is to collect and store water in the profile, because it's a dryland trial, water in the profile for the potatoes in the year to follow. All right. So this is not the functionality, diversity that Karen spoke about, which is of course very necessary. You cannot only look at, this is soil respiration, so it just gives you an indication of is there more microbes or not. And this is for 4 time points. The end of this, of the season when there was cover crop, sugar bean, soybean, and sunflower. And the first thing you can see is there are changes over the season. So it was the end of the season, start of the next season, and so on. And of course, that has to do with the fact that soils are drying out. After the winter, mid of the season, we see more microbes, and then respiration or higher respiration, and then by the end of the season, when it's dry, lower rates again. But also, if you look at the 4 different rotation systems, clearly one can see this one that had the cover crop, even in the consecutive year when there were maize in all these plots, still having higher respiration rates. So, although, and even now, after year 9, I've just received the results from the chemical and the physical analysis that we did, and really no meaningful differences, but we're starting to see, and also the functionality and diversity, we're starting to see, at least from the microbial side, positive effects. Also in this year, when we had maize after the various cover crop and the other beans and so on, we started seeing, we saw differences in the growth of the maize during the growing season. Maybe some of you guys were there with a green tour, and we saw the height differences between the maize, and that eventually also reflected in significant yield differences. Okay, so to conclude my short talk, initially we saw no rotation effects, especially in terms of soil chemical and physical properties. We believe that the annual tillage, which is the normal practice on that farm, promotes the breakdown of organic matter, and of course that feeds the microbes. So definitely the inclusion of the cover crops, we're starting to see differences between rotations, not necessarily in terms of the soil chemical properties, which take a long time, and if we read the literature and we hear from other trials, it is also the case there that it takes a long time to start to appear. At least we're starting to see the effects in the biological properties or activity of microbes in the soil. So lastly then, just help me with the last one, please. Oh. All right, so definitely soil chemical physical properties take a long time to change. I think because of the fact that we also do not have different tillage practices in, we don't have a residue layer, those practices for conservation agriculture, which because of the system that we are in are not practiced and are not practical. But at least the rotation we're starting to see, and I think the problem with a slow change initially is the fact that, I mean, you don't have these other positive contributing factors that help the system to recover. Okay, thank you very much.